This is a low-level video on recursion. For this low-level video, we're doing this project called base conversion. And what this does is it takes a number given in base 10 by a user, and it requests that the user have a number in base 10 and a base to convert that to. And then this project will call a method called convert, and that convert method will output the number in string form converted to that base. So say you have like the number 2 and you're converting that to base 2, it'll show the binary representation of 2. So it uses two methods to accomplish this. So the first method is non-recursive, and it's called digit to string. And what this method does is it takes one number and it will convert it to its hexadecimal representation. So for numbers 1 through 10, it will just output 1 through 10. But for the A, B, C, D, E, F of hexadecimal, it will take the decimal representation of that. So say 10, it'll convert it to A. And this only works for one number. So if you have like a number that's say like 255 and you put that into digit to string, it's going to not emit like a letter representation. So that's what the convert method is for. This convert method takes a number. It can either be above base 10 or below base 10, and it takes the raw number given in base 10, and it uses recursion to convert that integer into a string representation. So the first thing is it has a base case. So if the number is equal to 0, it returns an empty string. And this is universal in every single base. 0 is just equal to nothing. So if it's number 0, returns nothing. If the number modded by the base is greater than 9, so it's 10, 11, 12, should be up to 15. If it's hexadecimal, it'll return, so it'll call convert again, and that it'll divide the number by the base, and then it'll add the digit to string representation of that number. So say you have something like 255, it will return F at the end, and it'll be convert number, and then it'll be like say 255 divided by 16 plus F. And then finally it has a case for if it's less than 10, it'll return convert, and then it will add just the number modded by the base. So for say binary, the highest number that this could represent is 1. So now let's go and try and run this. So we can compile it with Java C base conversion.java, and now we can do Java base conversion. So we give it an integer. Let's try one that's lower than base 10. So let's try to convert 255, and let's convert that to base 2. And that'll be just a lot of ones in succession, because 256 of course would be 1 at the beginning, and then all those 1s right now would be 0s. And now we can try this again with something that's bigger. So we can try base 16. So we give it the number 255, enter the base 16, and it'll convert it to FF. So of course this works for both use cases of the base being below base 10 and the base being above base 10. And it's just using recursion. It could use iteration as well, like the recursive message in base conversion. Like convert, this could be iterative, but by using recursion, it looks more intuitive, even though it costs more processing power.